Hey there, fellow space explorer. Ready for another deep dive? We're tackling some seriously big questions this time. The kind that keep you staring up at the stars and wondering.
It's amazing, isn't it? The universe just has this hold on us.
It really does. And when I look up at the night sky, one of the things that blows me away is knowing our galaxy, the Milky Way, has hundreds of billions of stars. Hundreds of billions.
It's almost impossible to wrap your head around, right?
Totally, but it gets me thinking, with that many stars, gotta be some planets out there like ours, maybe even other life forms looking up and asking the same questions.
And that's what we're diving into today. We're exploring the Milky Way, the possibility of alien life, even those mysterious black holes. You had some thought-provoking questions, so let's launch into it.
Let's do it. And to kick things off, I was reading that the Milky Way has somewhere between 100 and 400 billion stars. That's a lot of potential for, well, everything.
It really is. I mean, when we talk about the Milky Way, we're talking about a galaxy, a massive system of stars, gas, dust, all held together by gravity. And ours is a whopper, spanning something like 100,000 to 120,000 light years across.
Whoa, hold up. Light years. Just a reminder for those of us who don't have astrophysics degrees.
Right, sorry. A light year is the distance light travels in a year. And to give you an idea of how insanely far that is, light travels at about 186,000 miles per second. So yeah, even one light year is an unfathomably long distance.
Okay, so we're talking mind-boggling distances here. But if the Milky Way is that big, are there even bigger galaxies out there?
Oh, absolutely. Our galaxy is pretty massive, but it's not the biggest kid on the cosmic block, not even close. There are galaxies out there that make the Milky Way look like, well, a tiny little speck. Take IC 1101, for example. It's a supergent elliptical galaxy, one of the largest known galaxies in the observable universe.
Okay, so how much bigger are we talking? Like twice the size, 10 times.
Try 50 to 60 times larger than the Milky Way. It's estimated to be about 5.5 million light years across. Just absolutely colossal.
Wow. Okay, that really puts things into perspective, but I guess it makes sense, right? If there are these mega galaxies out there, there must be some on the smaller side too.
Exactly. We call those dwarf galaxies, and they're kind of like the opposite end of the spectrum. They can be absolutely tiny compared to something like IC 1101 or even our own Milky Way.
So if the Milky Way is a bustling city, dwarf galaxies are like quaint little towns.
That's a great way to put it. They still have billions of stars, but they're just on a much smaller scale.
It just blows my mind, all that variety out there. So, with all these billions upon billions of stars and all these galaxies, are we really alone in the universe? That's something I think about all the time. What are the chances?
It's the million-dollar question, isn't it? And statistically speaking, the odds of us being the only intelligent life out there are astronomically low.
Astronomically low, huh? So you're saying there's a good chance we're not alone?
I'd say so. I mean, think about it. We've already discovered thousands of planets just in our own little corner of the Milky Way, and we're constantly finding more.
True, true. But still, no signs of alien civilizations yet. No little green men waving back at us.
Well, that's where things get really interesting, is that whole where is everybody problem. It's called the Fermi Paradox, actually.
The Fermi Paradox. Catchy. So what's the explanation? Why haven't we made contact yet?
Well, nobody knows for sure. That's the paradox. But there are a lot of theories. One idea is that maybe we're looking for the wrong signs.
What do you mean?
Well, we tend to focus on finding radio signals, right? But what if more advanced civilizations have moved beyond radio waves? It'd be like trying to find a bustling city by listening for smoke signals.
Ah, I see. So our tech might just not be advanced enough yet to pick up on what's out there.
Exactly. Or what if these other civilizations are intentionally staying silent?
Intentionally? Why would they do that? Seems kind of rude.
Well, imagine the universe is like a dark forest. Every civilization is a hunter, armed and hidden in the shadows.
Okay, getting a little creepy here.
Think about it. You don't know the intentions of the other hunters. Maybe they're friendly, maybe not.
So, better to stay quiet, stay hidden, just in case.
Right. It's a theory known as the dark forest theory. And it makes you think twice about trying to shout out into the vast emptiness of space, doesn't it?
It does. Maybe those Voyager golden records weren't such a good idea after all.
Well, it's a complex issue. But it does raise another fascinating question. If we did want to make contact, how would we even go about doing it safely and effectively?
Yeah, good point. Those messages in a bottle probably aren't going to cut it, are they?
Probably not. Radio waves spread out and get weaker over distance. Plus, the universe is full of natural radio noise.
So it's like trying to have a conversation at a rock concert. Tough to be heard.
Exactly. So if we really wanted to get noticed, we'd need a signal that's, well, a little more obvious. Something that screams, hey, we're here, we're advanced, and we figured out how to do something amazing.
Like what? Building a giant neon sign around the solar system?
Well, not quite. But there's some pretty mind-blowing ideas out there. One that gets tossed around is the Dyson Sphere.
Dyson Sphere. Okay, I've heard of that. But remind me, what is a Dyson Sphere again?
So imagine a sphere so large that it completely encompasses a star. Like the entire star is inside this giant shell.
Whoa. Okay, I'm picturing it. But why build something like that? Seems like a lot of work.
The idea is that an advanced civilization could capture all the energy output of their star. We're talking about an unimaginable amount of power.
Wow, so we're not talking about a little solar panel here and there. We're talking about harnessing the power of an entire star.
Precisely. And think about it. A structure that massive would be pretty hard to miss, right? It'd be a beacon announcing our presence to the universe.
A cosmic "we're here" sign. I like it. Okay, so Dyson Spheres, definitely on the list. But let's shift gears for a moment. One of our listeners wrote in with a question about antimatter.
Antimatter, huh? Always a fun one.
Right. It sounds like something straight out of Star Trek.
Well, it's very real. And it's about as powerful as it sounds.
Okay, so for those of us who haven't taken a deep dive into particle physics, what exactly is antimatter?
In the simplest terms, it's like the opposite of matter. Every particle of matter has an antimatter counterpart. And when they meet, they annihilate each other.
Annihilate, as in big explosion.
You could say that. They convert their entire mass into pure energy.
Okay, that sounds kind of dangerous.
It can be. Even a tiny amount of antimatter, if it comes into contact with regular matter, releases an incredible amount of energy. More than a nuclear bomb.
Whoa. Okay, so maybe handle with care. But that also makes it a potential energy source, right?
Theoretically, yes. Antimatter has the highest energy density of any known substance.
So could we, build a spaceship with an antimatter engine and travel to other galaxies?
Well, that's where things get tricky. The biggest challenge is producing and containing antimatter. Right now, we can only create tiny amounts in labs, and it's incredibly expensive.
So not exactly a viable fuel source just yet.
Not yet.
But maybe someday.
Okay, so antimatter is out there, full of potential, but also incredibly volatile. Kind of like my cooking.
Maybe we'll stick to exploring black holes for now.
Speaking of, I've always been fascinated by black holes. What happens if you fall into one? Is it instant doom or something even stranger?
It's instant doom, right? You get sucked in, crushed into oblivion. At least that's what I've always pictured.
Well, it's a bit more complicated than that, actually.
Complicated how? Don't black holes have, infinite gravity?
They do have incredibly strong gravity, yes.
Yeah.
And as you get closer to a black hole, that gravity increases exponentially. That's where the idea of spaghettification comes in.
Spaghettification. Yeah, we touched on that earlier. Basically, you get stretched out like spaghetti as you fall in, right?
Exactly. The gravitational pull on your feet would be so much stronger than on your head that you'd be stretched out longer and thinner.
Okay, yeah, not a pleasant way to go. But what if, and I know this is pushing it, but what if there were ways to survive even that? The source material mentions some pretty wild stuff, like wormholes and quantum tunneling. Any chance those could save us from becoming cosmic spaghetti?
Well, we're venturing into highly speculative territory here. But yeah, some physicists believe that these concepts could play a role in what happens inside a black hole.
Okay, so let's break it down. First up, wormholes. I think I get the basic idea. They're like tunnels through space-time, right? Shortcuts.
Exactly. Imagine folding a piece of paper in half, so two distant points touch. A wormhole is like a tunnel connecting those points, a shortcut through space-time.
So instead of getting stretched out by the black hole's gravity, you're saying we could theoretically zip through a wormhole and pop out somewhere else in the universe?
Theoretically, yes. Now, it's important to remember that we haven't actually observed wormholes directly. They're still very much in the realm of theoretical physics.
Right. Still, pretty cool to think about. But what about quantum tunneling? That's even weirder to wrap my head around.
It is strange, but it's a real phenomenon that we've observed at the subatomic level. Basically, particles can pass through barriers that they shouldn't be able to, thanks to the probabilistic nature of quantum mechanics.
So they can teleport through walls.
In a way, yes. It's not exactly teleportation as we usually imagine it, but the end result is similar. And some physicists believe that similar quantum effects could occur inside a black hole.
So you're telling me there's a chance, however slim, that we could use quantum tunneling to escape the clutches of a black hole?
Again, it's highly speculative, but it's a fascinating possibility. And who knows, maybe someday we'll have the technology to test these theories out.
I like the way you think. Okay, so black holes might not be the end-all, be-all of destruction. Maybe they're gateways to something else. It makes you wonder, if our universe is inside a black hole, what's outside our event horizon?
That's the ultimate question, isn't it? It's a question that may never be answered, but it's one that drives our curiosity and pushes the boundaries of our understanding.
It's mind-blowing. And a little terrifying, to be honest. But mostly mind-blowing. Well, I think we've given our listeners a lot to ponder today. Any final thoughts before we wrap up this cosmic adventure?
Just that the universe is full of wonders we're only beginning to glimpse. There's so much more to discover, and that sense of wonder, that thirst for knowledge, that's what keeps us exploring.
I couldn't have said it better myself. Thanks for joining us on this incredible journey, and remember to keep looking up and asking those big questions. Until next time, fellow space explorers.